Hey guys, now in this video we shall study about highway materials such as soil subgrade, aggregate and bitumen by answering 10 questions. Now let's start with the first one. The first question deals with plate bearing test. The modulus of subgrade reaction corresponds to a pressure of 0.125 kg per centimeter square, 0.25, 0.152 or zero point 0.7 kg per centimeter square. This is a criteria that to be followed as per Indian standards. The modulus of subgrade reaction corresponds to a pressure of option D 0.7 kg per centimeter square. So this is the plate load test setup. Plate or we can say plate bearing test. We can also say like that. Here there will be stacked plates, and this is the hydraulic jack on above which we are loading at a rate of we shall see the specifications here. So for plate bearing test, standard size of plate shall be 75 centimeter diameter, and average settlement will be 0.25 mm and at the rate 0.025 millimeter per minute. So this will be the settlement rate according to which we have to load on this. So average settlement is 0.25 and at the rate of 0.025 mm per minute. And for the deformation 0.125 centimeter, we have to find the pressure. So this is the basic criteria, like modulus of subgrade reaction, it's denoted by small k and is given by k is equal to p by 0.125 kilogram per centimeter square per centimeter, or roughly we can say kilogram per centimeter cube. So p is the pressure corresponding to the deformation 0.125 centimeter. And this plate load test condition shall be performed for soaked and unsoaked. So this is for the corrections in pressure. So that's why soaked and unsoaked condition will be there, on which um, we have to perform the plate load test. So the relation between soaked and unsoaked condition shall be like this: Ps by K is equal to Pi by K. So this is the relation, and accordingly we have to check for the corrections, check for any corrections if there. And for rigid plate, we shall follow this equation or this formula. Del is equal to 1.18 Pa by E. E is the Young's modulus of the soil subgrade, and A is the radius of plate. So whatever the plate we have considered, like 75 centimeter diameter plate, then 75 by 2 is the radius of plate. And in case of flexible plate, if we are using flexible plate, then del or the deformation shall be given by del is equal to 1.5 Pa by E. So these 1 2 3 4, these four are the basic relations and important formula. And this plate load test specification is given by IS 9214 1979 publication. In that IS code, the setup is given like this. So here you can see the plate here is 75 centimeter diameter plate, and the plate above which is 60 centimeter, and above that 45 centimeter. So some stacks of plate, some stack of plates will be laid here, and 75 centimeter is the basic and standard dimension of the diameter of plate. So this is the basic setup as given by IS 9214. So these are the basic points to be noted in case of plate bearing test for the subgrade soil. Now we shall move on to next one. This question is based on California bearing ratio. So here they have given the question as CBR value is taken for penetration value 2.5 mm or 5 mm or 2.5 mm when if only it is greater, or whichever is smaller. So what is the CBR value we have to take? That is the question. For which penetration value the CBR value has to be taken or adopted. The option is C 2.5 mm, and if and only if it is greater, not just like 2.5 mm has some one value and 5 mm penetration has one value. Not blindly we have to take a 2.5 mm value. Only if it is greater value for CBR, then we have to take that value as the CBR value to be adopted. And basically 2.5 mm penetration will be the CBR value in most cases. In some cases, like if we are using high swelling soil like clay, then there may be some fluctuations between 2.5 mm penetration and 5 mm penetration. For those soils, we have to repeat the test. If CBR value at 2.5 penetration is less than that of 5 mm, then the test has to be repeated, and next we have to adopt the higher value. If the higher value comes for 5 mm penetration for that condition, then that has to be adopted. But basically, in general, CBR value at 2.5 mm penetration will be greater than 5 mm. So CBR value at 2.5 mm penetration will be taken. This CBR percentage value will be given by the ratio of load carried by specimen at 2.5 mm or 5 mm penetration to the corresponding load carried by standard aggregates at corresponding penetration. So here in this table you can see, for standard load in case of 2.5 mm penetration, the standard load will be 1370. This standard means they are using standard aggregates. So for that standard condition, for 2.5 mm penetration, it shall be 1370 kilogram, and in case of 5 mm penetration, it shall be 2055. And for CBR test, we are using 150 mm mold. Here in this diagram, you can see this mold is of diameter, inner diameter 150 mm, inner diameter of mold is 150 mm, and soaking. This sample has to be soaked for 96 hours, or we can say 4 days. And the plunger here is of diameter 50 mm, and the plunger penetration rate shall be around 1.25 mm per minute. So these are the specifications in case of standard CBR test. And we can classify the soil according to the CBR value that we have obtained. In case the CBR value obtained is is falling in this range 2 to 5% for a clay soil, then we can rate that subgrade shall be as a very poor subgrade. Uh, that means we have to follow some reinforcement techniques like geogrid reinforcement in order to make sure that vehicle load is transmitted smoothly. And if the CBR range falling below 5 to 8, and for that will be in case of silty soil, then that subgrade will be classified as poor one. And in case of 8 to 20 for sandy soil, it can be rated as fair to good subgrade, and the excellent one is the gravel. And for gravel, CBR range will be 20 to 30%. So these are the basic important points to be noted in case of California bearing ratio CBR value. The most important is this 2.5 mm penetration. So at value 2.5 mm penetration, if it is greater than that for 5 mm, then no problem, the farmer has to be adopted, like whichever the value we got for 2.5 mm penetration shall be the CBR value. If at all 2.5 mm penetration CBR value is less than that of 5 mm, then the test has to be repeated and higher value has to be adopted. Now we shall move on to third one. This question deals with the aggregate test. So here in crushing test, dry aggregates passing from which ISE and retained on which ISE has to be taken as a sample of dry aggregates. So which is the ISE on which the sample of aggregates should pass through, and those sample of aggregates should retained on. Here the answer is option D, 12.5 mm passing, 10 mm retained. This is the standard ISU and standard specifications for crushing test as well as impact value test. Now we shall see more points about it. In case of aggregate crust value, when we are considering very strong aggregate, then this value shall be less than 10%. When we are using those aggregate for surface cores, then it shall be less than 30%. When it is less than 35%, we shall consider those aggregate as weak. And when we are using for base course, then this ACV value shall be around 45%, less than 45%. And for this ACV, we are using 40 tons load at 5 tons per minute loading rate, and each layer will be tamped for 25 times. After that only we are applying this load, and the crust aggregate shall be sieved on 2.36 mm, and the weight on the sieved aggregate divided by the total weight we have taken as the sample of dry aggregates into 100 gives the value of ACV, aggregate crushing value. And similarly we have aggregate impact value, AIV. And similarly we have some conditions, like if it is less than 30%, we can use those aggregate as surface course. If it is less than 35%, we can use in bituminous macadam. If it is less than 40%, we can use those as waterbound macadam, those in waterbound macadam. Here also we have like 13.5 kg load at 5 tons per minute loading rate, and for each layer 25 times stamping will be given, and here free fall of 38 centimeter will be given. Why? Because this is impact value, that is we are testing for toughness of that aggregate. Here ACV is crushing, so there is no free fall. Just it is similar to a compression test of concrete. So similarly, that one we apply only 40 tons of load at 5 tons per minute loading rate. And the crushed aggregate after this after ACV test or AIV test, there will be crushed aggregate, and those crushed aggregates shall be sieved on 2.36, and weight will be taken divided by total weight, and 100 gives the percentage for AIV and ACV. These are the simple things we have to follow. And next test is the abrasion test or attrition test. And after attrition or abrasion test, like Los Angeles abrasion test, Dover attrition test, like that. Actually what abrasion is, abrasion means rubbing action occurring between aggregate and steel or the drum material or the Los Angeles apparatus material. Attrition means the rubbing action between two aggregates. If the rubbing action between two same material, that will be called as attrition. If the rubbing action will between two different materials, for example aggregate and steel, then that will be called as abrasion. And after this test there will be some crushed aggregate, and that aggregate will be passed on 1.7 mm sieve. So by using that, the coefficient of hardness shall be calculated by using this formula: 20 minus loss of weight of aggregate in grams divided by 3. This is the basic points regarding Los Angeles abrasion or attrition test. If abrasion value is less than 30%, we can use those aggregate as surface course. If it is less than 50%, we can use that as base course. So these are some points regarding aggregate test. Now we shall see the apparatus of it. Like this is the apparatus setup for aggregate crushing test. So this is the tamping or the compacted aggregate after 25 times stamping for each layer, and we are crushing the aggregate by using some loading like 40 tons at 5 tons per minute, and the crushed aggregate will be taken sieved through 2.36, weight will be taken divided by total weight into 100. That will be that give the answer for ACV. And similarly this is the impact value, and this is the free fall, like this is the free fall of 38 or around 38 centimeter. 38 centimeter is the free fall in case of impact value test. And next what is the next one? This is Los Angeles abrasion test. Here drum will be there, it will be rotated for some standard rotations per minute, and after which crushed aggregate will be obtained, and that aggregate will be sieved on 1.7 mm, and weight will be taken divided by the total weight of aggregate taken into 100 gives the abrasion value. Same procedure but different specification and different apparatus. And for AIV and ACV, the dry aggregate shall be taken as a sample passing from 12.5 mm ISA and 10 mm retaining on ISA. These are the standard specifications regarding the aggregate testing. Now we shall move on to the next fourth question. This question is also based on a similar aggregate test. The weight of coarse aggregate having specific gravity 2.65, which is completely filled into a cylinder of volume 0.003 meter cube, is 5247 grams. So weight of coarse aggregate is given as 5247 grams, and we have to calculate the angularity number. That is one simple formula for angularity number calculation. We have all the known datas. Just fit those datas in the formula for angularity number so that we can get the answer. Here the answer is option D, 1%. Now we shall move on to calculation. First, let's see the given data W suffix A, that is weight of aggregates 5247 grams, or we can call it as 5.247 kilograms. And we have, and in the formula, first let's see the formula and let's denote the data. Angularity number will be given by 67 percentage minus WA by WW into GA. This WA is weight of aggregate, WW is weight of water, GA is specific gravity of aggregate. So we know all the things. WA 5247 gram or 5.247 kilogram. And what is WW? Weight of water. We know the density of water as 1000 kilogram per meter cube. They have given the volume of the cylinder and it is completely filled, so that we shall take that as 0.003 into 1000. That will give us the answer for as 3 kilogram of weight of water. And specific gravity of water is 2.65. So 67 minus 5.247 divided by 3 into 2.65 gives 66. So 67 minus 66 is equal to 1%. This is the angularity number that we have calculated. And this angularity number measures the degree of packing, and it measures voids in excess of 33%. So in this formula you can see 67 minus this, so that means voids in excess of 33%. And the range of angularity number will be lying between 0 and 11. 0 to 11 will be the angularity number, and if the angularity number is 0, that represents the most practicable rounded aggregate. That means it contains voids of 33%. And in case of angularity number 11, then that will be representing the most angular aggregate that could be used for making concrete. Most angular aggregate means there will be much interlocking like that, very sharp aggregates. So that could be used for making concrete. So this is the angularity number criteria and information. And next we shall see another thing called shape test for aggregates. Shape test will be given for aggregate of size greater than 6.3 mm. This is one important one. Only when the aggregate size is greater than 6.3 mm, shape test shall be performed. There are two things: flakiness index and elongation index. What is flakiness index? It is the percentage by weight of aggregate particles whose least dimension is less than 0.6 times the mean dimension. Here you can see the slot. This slot is used for flakiness test. This is used for elongation test. And if we are using if we are using this slot and this slot, and what is the average size between this slot, that has to be taken as the mean dimension, and zero point 0.6 times that mean dimension shall be greater than the least dimension, or least dimension is less than the zero point 0.6 mean dimension. Then that aggregate particle will be called as flaky. If at all it is more, then that aggregate is not flaky. I hope you understand that point. Flaky index means percentage by weight of aggregate particles whose least dimension is less than 0.6 times mean dimension. So this is the slot. And for elongation index, similarly, this is the elongation index slot. For example, we are taking this slot and this slot, and the mean value of this slot and this slot has to be taken and multiply that with 1.8. So when one aggregate has the greatest dimension, that is the lengthwise dimension is greater than 1.8 times the mean dimension, then that aggregate will be called as elongated aggregate. So percentage of those aggregate particle has to be taken uh, as a elongation index. Similarly for flakiness, and this flakiness index shall not be more than 15. Similarly elongation index shall not be more than 15, and combined index shall not be more than 30. This is the criteria for road aggregates. And we have seen many tests on aggregates from the abrasion test, ACV, AIV. Now here angularity number, shape test, like that. Now we shall move on to the next part. Again, the aggregate test. That is here soundness test. In soundness test of aggregates, average loss in weight of aggregates to be used in pavement construction after 10 cycles should not exceed 12% when tested with sodium sulfate, 18% when tested with magnesium sulfate, 12% when tested with salt, 18% when tested with magnesium hydroxide. So which is the chemical that shall be used uh, to calculate the soundness test. Soundness means it is related to volume, like the volume of aggregates should not loss. So average loss in weight of aggregates to be used in pavement construction after 10 cycles. 10 cycles means 10 times we are checking, should not exceed 12%. That loss in weight should not exceed 12% when tested with Na2SO4, and in case of MgSO4 it should not be greater than 18% loss. The resistance of aggregate against weathering action by conducting accelerated weathering test cycles. That is the soundness test. That is nothing but there should be no fluctuation in or reduction in the volume or the loss in weight of the aggregates. Then that will be called a sound aggregate. If at all that loss is more than 12% when tested with sodium sulfate, then unsound aggregate we can call it as. So this test is performed like the soak, you have to soak the aggregate in this solution, or either of this solution, for 24 hours. And in case in the either case, we have to follow this criteria: 12% in case of Na2SO4, 18% in case of NgSO4. These are the things regarding soundness test. Now we shall move on to other tests like water absorption, specific gravity. Water absorption should not be more than 0.6% of weight of the aggregate. This is the basic of specific and basic criteria regarding water absorption. And the specific gravity of aggregate lies between 2.6 and 2.9. So the specific gravity indicates the strength of material, like the strength of the aggregate. So 2.6 and 2.9 shall be the specific gravity of aggregate. And we have seen almost all the tests on aggregate. Now we shall move on to the other materials. So that is nothing but bitumen. We start with the Marshall bituminous chest. So in a Marshall sample, they have given some data. G suffix T, that is theoretical gravity, theoretical specific gravity shall be it's equal to 2.441, and bulk specific gravity is 2.324, and GB is the bitumen specific gravity is 1.10, and the weight of bitumen by percentage is given as 5%. Which of the following data are correct regarding this given data? This problem is based on Marshall bituminous mix design. We shall see one by one the formulas. So here all the options are correct: VMA, VFB, VV, VB. So what actually is the V suffix V? Volume of voids in percentage. So that will be found by using this formula: GT minus GM by DT into 100. So 2.441 minus 2.324 divided by 2.441 into 100 gives the answer as 4.79. And next, VB, volume of bitumen, is equal to GM into WB by GB. GM, nothing but bulk specific gravity. WB is the percentage of bitumen weight, or we can say weight of bitumen by total percent, divided by GB, specific gravity of bitumen, that is given as 1.1. Just substitute here and get the answer for VB as 10.56%. Next is the VMA. Volume of mineral aggregates is VV plus VB. Just add both the things together to get the answer for VMA, that is 4.79 plus 10.56%. 15.35 is the answer for VMA. Next is the volume filled in bitumen. What's filled with bitumen? It's VFB, VB by VMA. So we know all the things. So all the options are correct. So this is a phase diagram in case of bituminous Marshall bituminous mixed design. So coarse aggregate 1, 2, fine aggregate, filler, bitumen, air voids. That is VV. Here we are denoting the volume. Here we are denoting the weight. Total weight is Wm. Total volume is Vm. That is mass or bulk volume. We can call that as. And in case of theoretical specific gravity, that is G suffix T, that shall be found by using this relation: 100 by W1 by G1 plus W2 by G2, W3 by G3, W4 by G4 without volume of voids. That is the theoretical specific gravity. And in case we are we are adding the volume of voids here, then that shall be called as what? Bulk specific gravity or mass specific gravity. This weight shall be in percentage. Like for example, weight of aggregate is some x grams and total weight of the sample is y grams. Then what is the percentage by weight of the bitumen? Just x by y into 100. That gives the weight of bitumen by percent. Similarly, we have to calculate for aggregate, coarse aggregate, fine aggregate, filler, like that. And substitute the correspond and divide the corresponding specific gravity value. For example, say for coarse aggregate, it shall be 2.65 or 2.7 or like that. Similarly, GM. So these are the important formulas like VV, VB, VMA, VFB, GT, GM. VV is volume of voids in percentage, volume of bitumen VB, volume of mineral aggregates VV plus VB, voids filled with bitumen VFB. And GT is theoretical specific gravity, GM is bulk specific gravity. And we shall see more points about Marshall mixed bitumen. There is something called stability. Stability is measured in kilograms. So that is nothing but maximum load carried by specimen at 60 degrees Celsius at the rate 50.8 mm per minute. So this is the stability criteria. Stability is measured in kilogram. And this is the specified value for a typical bituminous sample. For a Marshall stability in kilogram, the specified value shall be 340 kg. Minimum 340 kg of stability should be there for a good bitumen. And the flow value will be 8 to 17. What is the flow value? Flow is measured as deformation in units of 0.25 mm. So if the deformation is section 6 mm, flow value shall be 24 mm. Sorry, flow value shall be 24. So here flow value for specified as 8 to 17. So that means 8 to 17. That means what? Deformation is 8 into 0.25. So 8 into 0.25 means what? 8 by 4. So deformation is 2 mm. So similarly 17 into 0.25. So what actually is flow value is measured in the units of 0.25 mm. That is, if deformation is x mm, flow value shall be uh, like x by 0.25 mm. So that is the basic idea behind it. That is why 6 by 0.25 is equal to 6 into 4. That is equal to 24. That is the basic idea. And next is the uh, before moving to this point, we shall see this table. We shall finish this table. VV percentage, that is the volume of voids shall be 3 to 5 percentage, and voids filled with bitumen shall be 75 to 85 percentage. This is the specified basic value regarding a good Marshall bitumen. And the thickness of specimen in the Marshall bituminous testing shall be 63.5 mm. If at all it is fluctuating, there should be corrections applied. And the sample compacted by ramming 50 blows. So these are some points to be noted in case of Marshall bituminous mixed design. Now we shall see the graphs, some 6 graphs regarding this 6 graphs regarding stability, flow value, VMA, VFB, VA with respect to percentage bitumen content. So stability versus percentage bitumen content shall be like this. Uh, it is rising and getting an optimum value, and it is decreasing. So likewise, it shall be varying with respect to percentage of bitumen content. So just pause the video and refer this graph so that you can get an idea how every parameter is varying with respect to percentage of bitumen content. Now we shall move on to next seventh question. This question is also based on bitumen. So this rapid curing, medium curing, slow curing for cutback bitumen. In case of rapid curing cutback bitumen, what is the chemical has to be mixed? Similarly for medium curing, slow curing. So just match the following. For rapid curing cutback bitumen, we have to use naphtha or gasoline. For medium curing, we have to use kerosene. For slow curing, we have to use high boiling point gas oil. Now we shall see what is cutback bitumen and what are the other bitumens available. So what is cutback bitumen? It is the bitumen in which viscosity is reduced by volatile diluent. These are the volatile diluent. By mixing these chemicals or diluent, we can reduce the viscosity. That bitumen obtained is called as cutback bitumen. For rapid curing, we shall use naphtha or gasoline. For medium curing, we can use kerosene. For slow curing, we can use high boiling point gas oil. And there is another thing called bitumen emulsion. That is nothing but that bitumen suspended in aqueous medium. That is the bitumen emulsion. That will be used for patching up works. And rapid setting for surface painting. So there are three things: rapid setting, medium setting, and slow setting. So rapid setting bitumen emulsion is for surface painting. Medium setting for pre-mixing the bitumen with the aggregate or cross aggregate we can say, and the slow setting bitumen emulsion will be used for fine aggregate mixes. So these are the uses for bitumen emulsion. And we shall see more about bitumen and tar here. Bitumen shall be completely soluble in carbon disulfide, that is CS2, and carbon tetrachloride, that is CCl4. So this is a major and important criteria regarding bitumen. In case of tar, tar has to be completely soluble in toluene. What is that is a compound called toluene, in which tar has to be soluble. And there are four grades of tar: RT1, RT2, RT3, 4, and 5. This will be in ascending order, like this one, based on the viscosity. RT1 has the less viscosity, and RT5 has more viscosity, and each has specific application. Like for less viscosity, surface painting will be given. Like that, waterborne macadam in case of RT4. So like that, each RT, each rate of grade of tar will have some specific application. Now we shall see the specific gravity. Specific gravity of bitumen obtained from pygnometer test shall be around 0.97 to 1.02, and in case of tar it shall be around 1.1 to 1.25. So tar has somewhat more specific gravity when compared to bitumen. Bitumen specific gravity lies around 0.97 and 1.02, and the manufacturing of bitumen shall be based on the principle of fractional distillation. This is one important point. Fractional distillation is the principle by which bitumen will be manufactured. It is a petroleum product, unlike tar. Tar is a coal product. So we have studied some more points about bitumen. Now we shall move on to next question. So this question deals with the penetration test on bitumen. Here they have mentioned 80 bar 100 grade. So that means what? 80 bar 100 represents what? Whether it is 8 to 10 centimeter penetration or 80 to 100 mm penetration. or 8 to 10 mm penetration or 8 to 10 decimeter penetration. What is the representing term? Option C, 8 to 10 mm penetration is the representing term for 80 to 80 bar 100 grade. So bitumen penetrations test is to obtain the hardness. The parameter is the hardness. For obtaining the hardness value, we are uh, performing the penetration test, and this test shall be performed at 27 degrees Celsius, and weight shall be 100 gram, and 5 seconds of time will be taken for penetration. If that penetration is 8 to 10 mm, we can grade that bitumen as 80 bar 100. If it is 30 bar 40 like this, then the penetration value is 3 to 4 mm. This is the basic gradation. And penetration test is not used for tar because tar is soft when compared to bitumen. So that's why penetration test is not applicable for tar. In hot climates, lower penetration grade bitumen like 30 bar 40 will be used. In hotter climates, lower grade bitumen shall be used. And there is a denotation of A30. A30 means A refers to Assam Petroleum. So other than Assam, S will be used. So this is some point regarding penetration test on bitumen. And another thing, that there are many tests which I will see one by one now. Now we have completed the penetration test. This is the ductility test. 75 centimeter 75 centimeter ductile. That should be minimum for a grade of greater than 45. So here in this picture you can see this is the standard briquette actually. So that the standard briquette size shall be 75 centimeter. That should be the minimum. Actually, 75 centimeter is the length of the ductility, not the briquette size. Briquette size is 10 cross 10. This 10 cross 10 is the standard briquette size, and the 75 centimeter is the ductility value. Sorry for the confusion. And this ductility rate is 50 mm per minute. So this is the basic things in ductility test. So 75 centimeter is the minimum value of ductility for a grade above 45, and standard briquette size shall be 10 mm cross 10 mm, and the rate of uh, ductility test is 50 mm per minute. Now we shall move on to ninth one. Standard flash point according to Indian Standard Institute is. This is another test on bitumen, flash and fire point test. So what is the standard flash point? That is the what is the temperature at which standard flash point will be adapted according to Indian standards. Option D, 175 degrees Celsius, the standard flash point. Now we shall see the definitions of some uh, terms like a flash point, fire point, softening point, float test, like that. So first, flash point is nothing but the temperature at which bitumen vapors momentarily takes fire. There will be some vapor on bitumen when we are heating. So if that vapor takes a fire for some moment, for or say for 1 second or 2 seconds, so that temperature shall be called as flash point. And what is fire point? When the bitumen catches the fire and burn. What is that lowest temperature? That is the fire point. And the safe limit shall be 50 degrees Celsius below the flash point. That is the basic safe limit. For example, 175 degrees Celsius is the standard flash point. Then what will be the safe limit? 175 minus 50. That is the safe limit. And the apparatus used is named as Pensky-Marten's apparatus for flash and fire point test. And now we shall see other test on bitumen. One is the softening point test. That is the in standard value of softening point shall be between 35 and 70 degrees Celsius. And the test is called as ring and ball test. that is the softening point test. Here you can see. Here there shall be brass ring containing bitumen. On heating, there will be melting of bitumen. So at what degree Celsius? For example, 35 degrees Celsius, between 35 and 70 degrees Celsius, that is standard value. Bitumen will be softening and just melting over here. And next is the loss on heating test. Here we are testing for accelerated heat test, and 50 gram of bitumen at 160 degrees Celsius for 5 hours will be given, and the loss on heating shall be less than 1%. Then we can consider that bitumen as a good one. And next is the float test. In float test, the temperature is at 50 degrees Celsius, and this float test will be conducted when the bitumen for which penetration and viscosity is not used. When we are not using penetration value and viscosity value of the bitumen we have considered, then we can go for float test to test the consistency. So higher is the value of float test, stiffer is the bitumen. That is the basic idea behind float test. So these are some bitumen test. Now we shall move on to the last question. This question is also based on bitumen. So we have completed the test on aggregates, uh, almost completed the test on bitumen, and we shall move on to this question. It is desirable that the bitumen contains minimum water content. Why we have to consider minimum water content in a bitumen? What is the reason? Option A, to prevent foaming when heated above boiling point of water, or to increase the grade of the bitumen, or it should be made suitable for rainy seasons, or there is no relation with water content. What is the option? Option A, to prevent foaming when heated above the boiling point of water, there should be minimum water content in the bitumen. And what will be the maximum water content? It should not exceed 0.2% by weight. There should be minimum water content and maximum water content, but the limit of water content is 0.2%. And other tests are viscosity, solubility, and spot test. Viscosity test is done by using flux viscometers and at the temperature 25 degrees Celsius. And fluoral viscosity will be determined for liquid bituminous materials. These are some points regarding viscosity test. Viscosity test is different from penetration test. We should not confuse viscosity test with penetration test. Penetration test is used for to determine the grade of bitumen. Viscosity is a different thing. In penetration test, we are giving a temperature of around 27 degrees Celsius. Here in the viscosity test, temperature is 25 degrees Celsius. And next is the solubility test. This we have already seen. Bitumen should be soluble in CS2 and CCl4, and insoluble bitumen shall be less than 1%. That is, should not be greater than 1% by weight. And next is the spot test. So 2 gram of bitumen dissolved in 1 ml of naphtha. And in a paper, for example, in a paper, we are getting a spot. And after drying, there should not be no dirty things left. If no dirty things left, then that bitumen has no impurities. We can obtain a inference or solution. So 2 gram of bitumen dissolved in 10 ml of naphtha shall be made as a spot in a paper, and after drying out, there should not be no impurities left. So we have covered all the tests and specifications on highway materials like the subgrade, like a plate load test we have seen, and next we moved on to aggregates, and at last we have seen all the tests on bitumen. So we are at the end of this video. If you like this video, please like, comment, and share with your friends, and please subscribe the channel right now. Thank you so much.